I'm Anil Kumar, and in this series of related rate of change, here is another very interesting question. The question here is: a man 2 meter tall walks along the edge of a straight road 10 meter wide. On the other edge of the road stands a street light 8 meter high. If the man walks at 3 by 2 meters per second, how fast is his shadow lengthening when he is 10 meters from the post directly opposite the light? So here is a small sketch which reflects how we could solve this particular question. So here's 2 meter tall person walking on 10 meter wide road, and on the other side we have 8 meter high lamppost. The man walks at 3 by 2 meters per second, so we'll say dx dt is 3 by 2 meters per second. That's the direction in which this person is walking, and as the person walks, that is the shadow S, which is lengthening, and we need to find what is ds dt. That is what we need to find when the person is 10 meters away from the post directly. That means when y is equal to, when y in this case is equals to 10. This is what we need to find. So I hope this situation is absolutely clear. Have a good look and then solve the question. Now let us see how to relate x and shadow, these two things. Now x could be related with y, right? So we have one relation here. So we could always write y square is equals to x square plus 10 square. So that is one relation which we can always use. So we have related y with x, which is one thing. And second thing, we want to relate actually x with s. So we look into this vertical side. It's like a 3D question, right? So this triangle standing here. So we know this ratio 8/2 should be equals to big triangle, which is y plus s, over small triangle s. So we get the other relation as y plus s over, so the big triangle base, bigger base, smaller base, is equal to ratio of their heights, which is 8/2 or 4. Now that gives you the relation between y and s. Now we get a relation between x and y. You can clearly see, right? So let's cross multiply. So we get y plus s is equal to 4s, and that means y is equals to 4s minus s, which is 3s. So now we know y is equal to 3s. Now we can connect these two. That is most interesting part of the question, right? How do we get our equation to work with? Perfect. So let's connect these two, and as soon as we do that, we get our equation. This becomes, let me write down here itself, 3s whole square equals to x square plus, let me write 100 now. Okay. So that means 9s square is equal to x square plus 100. So we have related these two parameters, which is shadow length and the distance from the point directly opposite to the lamppost. Perfect. What we need to find is how fast is the shadow lengthening when he is 10 meters from the post directly opposite to light. So when this distance x is 10 meters, not y. So let me just make a correction here. When x is 10, is it okay? So we really want to find when x is 10, what is going to be the length of the shadow, correct? The initial conditions which we need to find when x is equals to 10, what happens to s? So we can write this as s square is equals to 10 square plus 100 divided by 9, right? Or square root of this will be s. So let me write s square first, and then we'll do square root. which is 200 over 9, or let's write 200 over 9, and then S is equal to 200 divided by 9 equals to square root. Answer equals to okay, so 10 square root 2 over 3, and in decimals it is approximately equals to 4.714. Okay, so that is the value of S when X is equals to 10. So these are the initial conditions which we are going to use. Okay, so now let's find the derivative and see what rate of change is. So for rate of change, we have our equation, which is 9s squared equals to x squared plus 100. So if I find the derivative, I get 9 times 2, 18, right? S times ds dt. Rate of change of shadow equals to 2 times x dx dt. So that becomes the equation when we differentiate with respect to time. Now we need to find what ds dt is, so let's isolate. So ds dt is equal to x over, when you divide this, you get 9s, right? 9s times dx dt. That's what you get. So that becomes your equation for rate of change. And now we can substitute the values which we have found, and that is, we know dx dt is given to us as 3 by 2 meters per second, x is 10 meters, and the value of s is 10 square root 2 over 3, and s is, or approximately 4.7, whatever you, let me write 10 square root 2 over 3, correct? So these are the initial values. Let's substitute them. So we have ds dt when x equals to 10 is equal to, x is 10 over 9 times 10 square root 2 over 3 times dx dt is 3 over 2. Correct? So that's what you get. Now from here you can cancel these 10s, and let me rewrite this as and 3 goes 3 times. Okay, 3 goes 3 times. So what we have here is this 3 comes on the top, right? And we are left with 3 over 2 square root 2, 2 square root 2. So that's what we get in meters per second. So that becomes the exact value. 3 over 2 square root 2 is that. No, this 3 also cancels with this 3 also cancels with 3. So we get 1 over 2 square root 2. Right, so we get 1 over 2 square root 2 as our answer. If you want to rationalize it, so you can multiply by square root 2. So you get square root 2 over 4 meters per second. So that is the answer for the given question, right? So there is no need to write this decimal thing. You could actually use the exact value. So that becomes a good answer. So that is how we can actually solve it. So it's not that difficult. However, that part, relating x with s, is kind of critical in this particular question. I hope you understand and appreciate it. Feel free to write your comments, share your views, and if you like and subscribe, that'll be great. Thank you, and all the best.